Alright, number 29, what's the value of b if negative 2, 3 satisfies the equation 1 half x plus b? So this is our x value, this is our y value, this is just a substitution. 3 is equal to 1 half of 2 plus b. 1 half of 2 is 1. Subtract the 1, b is going to get b2. Okay, which accurately states the number of faces, vertices, and edges of a rectangular pyramid. On this one, you can use the Euler's method or Euler's formula, or you can draw a rectangular pyramid to kind of help you visualize what's happening. So you got a rectangle, and then you have that going around. So you know you have the base, and then you got 4 sides. So that's going to give you 5 faces. So you can eliminate F and G. Vertices, you're going to have 1, 2, 3, 4, 5. So that means you can get rid of J. H is the right answer. Number 31, triangle DEF and GH are formed by intersecting lines, DG and HG, by additional lines segments DF and HG, where DF is congruent to HG. Which additional condition is sufficient to prove that DEF is congruent to GEH? Okay, so this is again going with the side angle, side theorems that we talked about way back when. All right. Notice that vertical angles, that's given. That's something that you would be automatically to say. So DF parallel to HG. If these two are parallel, what does that mean? Could you use that? If DG bisects EH, would you be able to use that? DG is parallel to EH. That wouldn't make sense because they would intersect, and I cross that out. DG is perpendicular to HG. Right, so looking at this, the only one that would give me a guarantee that I could use one of these 5 would be A, because that would give me a pair of alternate interior angles, and I would be able to use angle, angle, side. So those two would be out. Let's see now, 32, what's the measure of angle 1? Angle 1 is right here. I know that these 3 lines are parallel. So that tells me that 4 is 30, 5 is 30, and I know that 3 is 40 because these would be corresponding. These would be alternate interior. So 1, 3, and 5 would have to add up to 180. So I'm going to do 180 minus 70 because 30 and 40 would give me 70. So that gives me 110 degrees. Alright, number 33, Linda's divided her garden into 3 parts. What's the area of her garden? So I'm going to take these 3 pieces and find the area of each, add them up. So 15 times 30 for the first one gives me 450. Okay, see 30 minus 28, that's going to give me 22. So I know this length is 22. This is 15, so 22 times 15 gives me 330. All right. Then I have to find the area of this. I know that that's the triangle. I know this height is 30 because this is 30. If I have 15 and 15, that adds up to 30. So I know this much is 30. 45 minus 30 is 15. So I want to do 1/2 base times height. So 15 times 30, divide that by 2, gives me 225. So I have to add 450, 330, and 225 together. And I end up getting 1,005 square feet as the area of the garden. 34, the front and right side views is shown. This is the front view and the right side view. Which one would be the right view? Okay, the front view on this one works. Same thing with this one, and this one, because I'm going to see a 3x3 view. So I have to look at the right. I got a stack of 3, stack of 2, and then a stack of 1. So this one's out because I have this extra cube right here. Looking at this one, I have 3 here, I would have 2 here, and then 1 that I would see here. So that should be my right answer. I know this one's wrong because I have 3, then I would have 3 and 1 there. This one I'm going to have 3, 1, and 1. So it should be 3, 2, 1. So H is right. Number 35, according to the pattern. Okay, this is like the other problem, but we're looking at this. You want to go through these and see which ones actually work. Okay, you don't want to use the first one because usually the first one will work for all of these. You want to start at least with number 2 and then go from there. So I'm going to have 2 minus 1, 2 minus 1. That's going to give me 1 to the 1 power, which is 1. So that works there. Let's see if I can get rid of any of these other ones. 2 times 2 minus 1 squared. That's going to be 4 minus 1 squared, which is 3 squared, which is 9. That one doesn't work. 3 times 2, or excuse me, 3 to 2 minus 1 power. That's going to give me 3 to the first power, which is 3. That one works. And actually, I'm sorry, this one doesn't work. I'm supposed to be getting 3. Now, if I do 2 squared, that's going to give me 4. That doesn't work. So C is my only right answer. 36. In the figure below, lines A and B intersect lines C and D. Angle 1 and angle 2 are supplementary. So I know this one plus this one have to be 180. So then, and then the measure of angle 3 is 89. Okay. They didn't tell me anything else other than that they intersect based on the information below, which is the following statements is reasonable. All right, A and B are parallel. I have no way of knowing that because I don't know what angle 1 is equal to, and it doesn't tell me that it's equal to angle 3. Do I know C and D are parallel? Again, I don't know if anything on that just yet. Well, actually, if C and D are parallel, that means 1 and this angle right here would be congruent, and this angle have to add up to 180. So I know this angle and this angle have to be the same, so G is actually the right answer. There's no way for me to know anything about parallel, or excuse me, perpendicular. I know B and C are not perpendicular because angle 3 is 89, and it would have to be 90. And I don't know any information about the intersection between A and D. I don't have any angles there either to make any kind of conclusions.